My name is Maddie Mitchell, and this is the NMR Spectrum that I was given. For an NMR spectrum to be formed, if using a solid, you would need about 50 to 100 milligrams of the sample. However, we used a liquid, so in this case, there will be equal amounts of solute and solvent in the substance of our experiment. In this case, the solvent is the chloroform. However, the proton has been replaced. It's isotonic. It allows there to be a solvent without showing up on the NMR. Therefore, they just take the hydrogen out. That's why it's called chloroform D. Tetramethylsaline, 1 drop of it, and 0.25 milliliters of the chloroform added to the NMR tube. Use the chloroform second. That way we can rinse all the tetramethane down the bottle. Then we add our unknown solute, 0.25 milliliters of it as well, to the NMR tube. Stir slightly just to make sure it's all mixed properly in the NMR tube. After that, you're going to place collar on the tube and then shove it down in the NMR hole, and this allows it to reach the bottom and get it to the length that we need. You then pull it out of this hole and you clean off the bottom of the tube. That way there's no fingerprints or excess debris on the tube. And then finally you can place it in the NMR machine where it's going to be read. You're going to turn the dial on the left counterclockwise until it's at 12 o'clock position, and then make sure the sample's spinning. Then you're able to close the lid. You're going to open the RNMR shim, enter. You're going to open the PNMR software and then type in shim, enter to get magnetic ready, and then you're going to enter ZGH. It will auto zero to get green box. Once the zero is acquired, the box is going to turn gray. Then open a software NUTS and type AZ. Zoom the range without TMS region and right click. This is just going to get us the peaks that we want. Then type DP to indicate where the peaks are, and then you're going to press enter to get those peaks. Type 1D, double click left, single click right of the peak. So you're going to click left of the peak, right of the peak, and then click in the middle of the smallest peaks and click 1. This will give you the given ratio, not necessarily the protons, but it will give you the ratio of the peaks. Then you can hit enter to exit the integration. Then hit view, show integral view, and show peak labels. That's going to give you the labels as follows on the peaks. And then whenever doing this, there is going to be some overlap. It's not the greatest resolution. However, this is going to give us a peak that we are able to read. So in my spectrum, I have 3 noticeable peaks. My first one is sitting at 5.647 ppm. My second one up here is sitting at 1.997 ppm, and my third one here is at 1.65 ppm, and you can see the peaks below. So the ratios that were given to me were 1 to 2 to 2. However, that is just the given ratio. That's not actually going to be how it lines up with our unknown. Looking at our NMR spectrum here, our NMR information, we have this peak here is at 5.6. However, this is just an estimate. So in this 5.6, we can see that we should have a C double bond C alkene. And that is what I predicted this peak to be, a C double bond C. To continue, I have a peak at 1.99. And for this, I chose it to be an allylic. Even though allylic says 1.7, it's our peak at 1.99 falls right in between a carbonyl group and an allylic group. Therefore, we want this in our case, to be an allylic because we need to have a carbon attached to our C double bond C, which is what this is going to show. To continue for our last peak at 1.65 ppm, I chose this to be just a saturated CH group. Therefore, we're just going to have another hydrogen coming off of our carbon, giving us, we know from these peaks that we must have a C double bond C. To continue from the ratio of the hydrogens given, I know that once doubled, we should have, this shows our splitting pattern because we have, well, our splitting pattern would be, I chose this as a singlet, I chose this as a doublet because there's two distinctive peaks. However, it's hard to tell when there's such overlap. And then here I chose triplet, 1, 2, 3. However, we could also say multiplet. To continue, I doubled my ratios, so I had 2 hydrogens, 4 hydrogens, and 4 hydrogens, giving me a total of 10 hydrogens. So I found my molecule to be cyclohexane because we have our C double bond C. And we also, if you add up all of the hydrogens coming off, it's going to be equal to 10. That is why I chose cyclohexane as my unknown.